Good morning, students. Welcome back to chemistry class. Today we are going to study about uses of hydrogen peroxide and structure of hydrogen peroxide and about the introduction about the hydrides, the new topic that is about the hydrides. Okay, introduction about the hydrides we are going to study today. Okay, everyone should listen carefully and take notes. Okay, first upon uses of hydrogen peroxide. Uses of hydrogen peroxide. Okay, the hydrogen peroxide are used in water treatment. First use, hydrogen peroxide are used in water treatment. How this was used in water treatment? If the water containing many pollutants, means many metallic pollutants, for example the near the industrial areas water means there is many pollutants having there, many lead, iron, copper, these metals are dissolving in the water. Okay, so how we can purify this water? Many methods are having, but here hydrogen peroxide we can use to purify this water. Okay, how hydrogen peroxide is purified? Hydrogen peroxide oxidized. This is one of the very good oxidizing agent, so it is oxidized the unpolluted water and to become the unpolluted water, pure water we get. This is the first use. Second use, the hydrogen peroxide, it is used as the mild antiseptic. What do you mean by antiseptic? You know, antiseptic means if our body having any wound, we are going in hospital. First of all, they washed clearly. Okay, so washing purpose, they are using hydrogen peroxide to clean our wound. The hospital is using hydrogen peroxide because it is one of the antiseptic. Okay, understand and second third use, hydrogen peroxide are used in bleach in textile, used as the bleach in textile, paper and hair care industry. Okay, bleach means it is one of the cleaning agent. Okay, bleach in textile, paper and hair care industries. Okay, this is the third use of hydrogen peroxide. And another one use having the hydrogen peroxide, it is used to restore the white color of the painting, white color of the old painting. Okay, hydrogen peroxide is used to restore the white color of the old painting. Okay, how it is used to restore the white color of the old paintings? Suppose in the painting and the paint white white paint, the white paint means water washing. Okay, water washing, the white paint having the one of the white pigment. Okay, white pigment, which one is the white pigment? Means PB3 OH twice, CO3 twice. Okay, white pigment. What is the name of this compound? Lead carbonate hydroxide. Okay, this is the one of the white pigment. This white pigment contained in the paint. Okay, when we are applying the wall, the paint contain one of the white pigment, that is the lead carbonate hydroxide. This is the white pigment. When this white pigment, it reacts with the hydrogen sulfide in air. Okay, white pigment, it react with the hydrogen peroxide in air to form the black colored lead sulfate. Okay, so this white pigment when reacts with the hydrogen sulfide in air to form black color lead sulfate. Okay, lead sulfide, not sulfate, lead sulfide, PBS. Okay, so when we are using hydrogen peroxide in the paint, this hydrogen peroxide oxidized. Okay, this is one of the oxidizing agent, so it oxidized the black colored lead sulfide to white colored lead sulfate. Okay, so this hydrogen peroxide, it is used to oxidized. This white color, black color lead sulfide to white color lead sulfate. Understood? So the paint contain one of the white pigment. What is the white pigment? Pb3OH twice, CO3 twice, lead carbonate hydroxide. This is the white pigment, and when it reacts with the hydrogen sulfide H2S in air, it forms the lead sulfide PBS. Okay, so when we are using the hydrogen peroxide in paint, this hydrogen peroxide oxidizes the lead sulfide to lead sulfate. Okay, so PBS, this is called the lead sulfide. So when we are using PBS, it is the lead sulfide, and when we are using the hydrogen peroxide H2O2 in paint, it oxidized this lead sulfide to lead sulfate. Lead sulfide means PBS. So lead sulfate means PbSO4. PbSO4. Okay, and it oxidized to lead to lead sulfate, and we know hydrogen peroxide one of the oxidized and reducing agent. Both redox reaction takes place in the we are using the hydrogen peroxide. So hydrogen peroxide oxidize lead sulfate and it reduced to water H2O. Okay, understood? H2. So we have to balance the equation here. Here Pb, one of the Pb, here also one Pb. Sulfur here only one, here also only one. But oxygen here 4 oxygen having, but here only 2 oxygen. 4 plus 1 5 oxygen having, but here only 2 oxygen having. Okay, so we have to make here 4. Okay, because we have to balance the hydrogen also. So we have to make here 4. Okay, 4 means 4 oxygen plus 4 oxygen, 8 oxygen. Here also 4 into 2, 8 oxygen. Okay, hydrogen also balanced. No, 4 2s are 8. Here also 4 2s are 8 hydrogen. Okay, this is the uses of hydrogen peroxide. Uses of hydrogen peroxide. So how many uses are having? There are 4 uses given. First use, the hydrogen peroxide, it is used to treat treatment to oxidize the pollutants. Okay, water treatment. It is used in water treatment to oxidize the pollutants. Second use, it is used as the mild antiseptic. Third use, it is used as the bleach in textile, paper and hair care industry. And what is the fourth use? It is used to oxidize. Then we are going to study about black color lead sulfide to white color lead sulfate. Structure of hydrogen peroxide. Okay. Hydrogen peroxide. What is the formula for hydrogen peroxide? You know, H2O2. This is the formula for hydrogen peroxide. So here, what about the structure means? Here, 2 hydroxy group. Okay, how much hydroxyl group having here? H2O2 means 2 hydroxyl group. Okay, these 2 hydroxyl group, this is one of the hydroxyl group and this is another one hydroxyl group. These 2 hydroxyl groups are joined by a covalent oxygen single bond. Okay, covalent oxygen single bond. Understood. So all of you know about the covalent bond. I think all of you know about covalent bond means the bond formed between the 2 atoms by mutual sharing of pair of electrons between the 2 atoms. Okay, so this is the covalent bond for the oxygen and oxygen have between the oxygen and oxygen having one of the single bond. This single bond is called the covalent bond because the 2 oxygen atom mutually shared by the electrons. So by the sharing of electrons, this bond is formed. So this bond is called the covalent bond. Okay, understood. But this is the structurally, the hydrogen peroxide is represented by the dihydroxyl formula in which the 2 hydroxyl group do not lie in same plane. Okay. This is normally 2 hydroxyl group joined the single bond that is called a covalent bond, but structurally these 2 hydroxyl group, okay, this dihydroxyl formula means these 2 hydroxyl group, it do not lie in same plane. Okay, do not lie in same plane. This plane do not lie this like. Okay, so one of the way of explaining the shape of the hydrogen peroxide is that the hydrogen atom would lie on the pages of a partly opened book. Okay, the hydrogen in the hydrogen peroxide means two hydrogen atoms are connected with the oxygen atom. Okay, this is the structure of hydrogen peroxide. But here these two hydroxyl group, this is the hydroxyl group. These two hydroxyl group, it do not lie in the same plane. Same plane means this is samely. Okay, this is the same plane. It do not lie in the same plane. But the one of the best way to explain the shape of the hydrogen atom, this is the open book shape. Okay, open book shape. Hydrogen peroxide has an open book shape. So this open book shape, in this open book shape, the hydrogen atom, the two hydrogen atom having these two hydrogen atom, it is lie along the, it lie on the pages of the partly opened book. So this is one of the book. So this is the partly opened book. Okay, partly opened book. So this two hydrogen group. Okay, how much hydrogen group? Two hydrogen group. It lie. Okay, it lies. It is the one of the skew conformation structure. Skew conformation means the hydrogen atom, it is in slant position. Okay, understand? So here these two hydrogen atom lie on the pages of the partly open book. Okay, this is the partly open book. So these two hydrogen atom lie on the pages of a partly open book. And the oxygen atom, this oxygen atom, it along the spine. Okay, this is along the spine means it is in linear position. Oxygen atom, two oxygen atom having in the linear position, but the hydrogen atom, it is the skew conformation means it is slant position. Two hydrogen atom, it lie on the slant position. Okay, understand? That is the hydrogen atom lie on the open page of the partly open book. Okay, the pages of the partly open book. Understand? So this is the structure of hydrogen peroxide. Understand? So why? What is the reason for this skew conformation? What is the reason for this skew conformation? Because it is due to the repulsive interaction of the OH bonds with lone pair of electrons on the each oxygen atom. Okay, so this is the two oxygen atom. What is the atomic number for oxygen? 8. So what is the electronic configuration for the oxygen atom? 2,6. Okay, so what is the valence electron? How much valence electron having the oxygen atom? 6 valence electron having. So this 2 electron, 1, 2. Okay, this atom 1, 2, 3, 4, and other 2 electron, it is shared the electrons. Okay, how much electron for the oxygen atom? Total 6 electron. So 2 electron, it is does not involving any bond formation. So we call this is the lone pair of electron. How much lone pair of electron having? 2 lone pair of electron having. Okay, this is one lone pair, this is another one lone pair, like that here this oxygen also atomic number 8, electronic configuration 2,6. This oxygen also having the 6 electron in the outermost orbit. Okay, so 1, 2, 3, 4 electron, it is in lone pair of electron. These 4 electrons does not involving any bond formation. Okay, so we call this is the lone pairs of electron. Okay, another 2 electron extra having for the each oxygen atom. These 2 electron, 1 electron for this oxygen atom, 1 electron, it share this 1 electron to this hydrogen atom, and another 1 electron, it share this one electron with this oxygen atom. Okay, like that this oxygen also two lone pairs of electron having, and another one electron remaining two electron having. Okay, the one electron it share this one electron with this hydrogen atom, because hydrogen atom, you know, hydrogen atomic number 1, so only one electron having the hydrogen atom. So when hydrogen atom, it need one electron, so this oxygen share this one electron to this hydrogen atom. Okay, like that another one electron it share with this oxygen atom. Okay, so because of this is called the covalent bond, because this bond is formed by the sharing. Okay, these electron mutually share two electron to form this bond. Because of this bond is called as the covalent bond. Understand? So here why this Q conformation structure why is formed? Because of the repulsive interaction of the OH bonds with the lone pair of electrons on the each oxygen atom. Each oxygen atom having lone pair of electron. Okay, lone pair of electron. By lone pair of electron means the repulsive force having here, because the electron both opposite charge always attract each other, but same charge always repel each other. Okay, so here same charges having, here 4 electron extra electron having, here this option also 4 electron extra electron. Okay, extra electron rich compound, this. Okay, electron rich compound, so always it repel each other, because of here also 4 electron extra having, here also 4 electron extra having. So because of this, these two atoms are repulse each other. Okay, so because of the repulsion, the OH bond, okay, because of the repulsion, this OH bond is in Q conformation structure is formed here. Q conformation, the hydrogen oxygen, it is in slant position. Okay, slant position. Understand? Okay, this is the structure of hydrogen peroxide in gas phase or liquid phase. The same like structure, the bond angle here, the hydrogen oxygen bond angle. Okay, hydrogen this hydrogen and oxygen. Okay, this bond angle here 94.8 degree. Okay, 94.8 degree. The dihedral angle here, dihedral angle means the length. Okay, length of this angle, dihedral, this hydrogen, for this hydrogen angle 115.5 degree, 115.5 degree, and the length of these two oxygen atom, distance 1.47 Armstrong. Okay, and this hydrogen distance 0.95 Armstrong. Okay, this hydrogen and this oxygen distance 0.95 Armstrong. This is the structure of hydrogen peroxide is in gas phase. Okay, and the structure of hydrogen peroxide in solid phase, the angle will be differ slightly because of the hydrogen bonding. Okay, because of the hydrogen bonding. Understood? So what about the structure of hydrogen peroxide in solid phase? Means same like structure, that is partly open book structure. Okay, one of the open book structure here, the two hydrogen atoms are lie on the pages of the partly open book. Hydrogen atom lie on the pages of the partly open book, and two oxygen atom. Okay, two oxygen atoms can be considered to be lying on the spine of the book. Okay, spine of the book, and the bond angle. Okay, the angle of the book opened at the angle of 100 and 1.9 degree. Here in solid phase, hydrogen peroxide is in solid phase. The bond angle of hydrogen, oxygen and oxygen. This HOO bond angle, it expanded from this in liquid state, the gas phase 94.8 degree. Okay, the HOO bond angle 94.8 degree. But in solid phase, because of this hydrogen bonding in solid phase, the bond angle, HOO bond angle, it expands to 101.9 degree. Understood? Bond angle differ here. And dihedral angle here, the dihedral angle, it reduced to 90 degree, 90.2 degree. But here in liquid phase or gaseous phase, the dihedral angle, it is 115.5 degree. Okay, but here it reduced to 90 degree, 90.2 degree. Understand? And oxygen distance also reduced here. Oxygen distance, the length distance, it is reduced to 1.46 Armstrong. But here 1.47 Armstrong, here 1.46 Armstrong. Okay, understood? So this is the difference between the structure of hydrogen peroxide in two phases, gas phase and solid phase. Understand? So this two structure, it is the important, you should understand this. It is the non-planar, okay, non-planar and non-linear structure. It is non-linear structure or non-planar structure. Okay, it is in screws. Which structure? This is in skew structure. This is in skew structure, non-planar. Okay, it is in non-planar. It is in skew-like structure. Understand? And another one important thing you should understand here, this structure, it is hydrogen peroxide has the non-polar structure, non-planar. It is non-planar. It is asymmetrical structure. It is not all the atoms. It is not in planar. And another one came, the important things you should understand here, it is a non-polar structure. It has hydrogen peroxide as the non-polar structure. What do you mean by non-polar? The polar means, what do you mean by polar? Polar means both the positive and negative ions are having the same molecule. That is the polar. But this is the non-polar. Okay, for example, I am taking one of the example, water molecule, water H2O. You know, this is the structure of water. Here, only one oxygen is present here. So, only one oxygen also here. How much lone pair of electron having? 2 lone pair of electrons are having for this oxygen atom. Okay, and you know, oxygen 6 atomic number 8, 2,6 electron having in the outermost orbit. So 2 electron, it is shared by the 2 hydrogen atoms, and these 4 electrons are present as the lone pair. It is not involving bonding. Okay, so here the oxygen is one of the most electronegative atom. Electronegative atom means it always attracts the electron towards itself. Okay, so but hydrogen like to give the electrons. Okay, so this hydrogen atom, it like to give the electron to the oxygen atom, attract the electron. That time the hydrogen atom like to give the electron, so it becomes the positive charge. Hydrogen atom, it becomes the positive ion. 2 hydrogen atom, both 2 hydrogen atom, it becomes slightly positive charge. Okay, here oxygen, when it attracting electron means it becomes slightly negative charge. Okay, so both positive and negative charges present in same molecule, that is the polar molecule, polar. But in case of hydrogen peroxide, it is non-polar. Why it is non-polar? Because here OH bonds having OH bond, 2 hydroxyl group, it bonded with this 2 oxygen atom. Okay, so these 2 oxygen atom have a repulsive force having for the 2 OH groups. Between these 2 OH group, one of the repulsive force takes place there. Okay, so it is not attracting the electron from the hydrogen atom. It like to repel. Understood? This is the reason for the non-polar structure of hydrogen peroxide. Understood? Okay, students, all of you should note this concept. What is the structure of hydrogen peroxide? It is a non-polar structure and a non-planar. Okay, non-planar structure. It is not in planar. Okay, and 2 hydrogen atoms of the hydrogen peroxide, it is lie on the page of the partly open book. Okay, 2 hydrogen atom for the hydrogen peroxide lie on the page of the partly open book, and 2 oxygen atoms lying on the spine of the open book. 2 oxygen atoms lying on the spine of the open book. Okay, and the next point, the OOH bond. Okay, OOH bond angle in gas phase, bond angle of hydrogen peroxide in gas phase is 94.8 degree, and in solid phase it is due to the hydrogen bonding, it expand. In solid phase, due to this hydrogen bonding, it expands to 101.9 degree. Okay, and next point, dihedral angle of hydrogen peroxide in gas phase is 115.5 degree, and in solid phase it reduced to 90.2 degree. Okay, this is about the structure of hydrogen peroxide. Note it. And then we are going to study about hydrides. Another one topic, hydrides. What do you mean by hydride? Okay, hydride means H minus. Okay, it is one of the electronegative ion. Hydride ion, H minus. Okay, how it is formed? How it is this hydride? How formed? The hydrogen forms binary hydrides with many electropositive elements including metals and non-metals. Hydrogen forms binary hydrides. Binary hydrides means the hydrogen, it combines with any other compound. Okay, for example, lithium hydride, magnesium hydride, MgH2, LaH. Okay, calcium hydride, CaH2. Okay, understand? So this is the hydride, LaH. Okay, this hydride, it is formed, the binary hydride, it is formed, binary hydrides formed with many electropositive elements including metals and non-metal. For example, LaH. Okay, this is the hydride, one of the hydride. Lithium, it is one of the metal, you know. So lithium, it is one of the electropositive metal because it donate electron. Lithium atomic number 3, electronic configuration 2,1. So it always like to donate this electron and it becomes lithium plus. Okay, lithium cation. So the hydrogen forms binary hydrides with many electropositive element. So when lithium atom give one electron to the hydrogen atom, so hydrogen, it becomes hydride, lithium hydride, H minus. Okay, understand, lithium hydride. So here, so the hydrogen forms binary hydrides with many electropositive elements including metal and non-metal. Maybe it forms hydrides with the metals. Maybe it is a non-metal because for example NH3. Okay, this is one of the metal hydride. It is the non-metal. It is one of the hydride, but it is hydrogen. It is the hydride of non-metal, hydride of nitrogen. Nitrogen, it is the non-metal. Understand? And it also forms ternary hydrides. Okay, this is the binary hydride: lithium hydride, calcium hydride, magnesium hydride, sodium hydride. Okay, these are the binary hydride. Okay, it also can forms ternary hydrides. Ternary hydrides means with two metals. Okay, hydrogen can form its compound with two metals. Binary hydride means hydrogen can form compound with one metals. Okay, lithium hydride, calcium hydride, this is the binary hydride. Ternary hydride means the hydrogen can form compound with two metals. For example, lithium borohydride, LiBH4. So here hydrogen, it combines with the two metals, lithium and boron. And another example, lithium aluminium hydride. Here hydrogen, it compounds with the lithium and aluminium, two metals. These metals we called as the ternary. Okay, ternary hydrides. These compounds we called as the ternary hydrides. Understand? So hydrides, these hydrides, now we're going to study about types of hydrides. Okay, the hydrogen atom can forms binary hydrides with many electropositive elements, including metal and non-metal, and also it can forms the ternary hydrides with the two metals. Okay, and then we are going to study about what is the classification of hydrides. What are the classification of hydrides? The hydrides can classified as three types. Okay, three types according to the nature of bonding. Okay, which bonding is formed between the hydrogen and other elements. Depending upon that type of bonding, the hydrides are classified as three types. Okay, what are the types? Ionic hydride, covalent hydride, and metallic hydride. Ionic hydride, covalent hydride, and metallic hydride. Understand? So the hydrides formed with elements having lower electronegativity than hydrogen are often ionic. Okay, ionic hydride means the hydrides formed with elements having lower electronegativity than hydrogen. Okay, the compounds of hydrogen, that is for example lithium hydride, this is one of the metallic hydride. Okay, lithium one of the metal and hydride. Okay, so what do you mean by ionic? Ionic hydride means when the hydrides are formed with the elements having lower electronegativity than hydrogen. Means for here lithium, it is one of the lower electronegativity. It always it lost electron to becomes the positive ion. Okay, so lower electronegativity, it is called the bonding between the lithium and hydrogen. This is the ionic hydride. This hydride means ionic hydride because the bonding bond takes place between the lithium and hydrogen. It is the ionic bond. So this compound is called as the ionic hydride. Understand? And covalent hydride means the bonding, the compounds of the hydrogen, that is elements with elements having higher electronegativity than hydrogen. Okay, hydrogen compounds having higher electronegativity than hydrogen, it forms covalent hydride because the bond, for example ammonia, NH3, it is one of the hydride. Okay, a non-metal hydride. Here nitrogen, it is the high electronegativity than hydrogen. So the bond formed between these two, nitrogen and hydrogen, the bond is called a covalent bond. Okay, so this hydride NH3, one of the hydride of nitrogen, this hydride we called as the covalent hydride. And about metallic hydride, we will study tomorrow. Okay, this is the introduction about hydrides. Tomorrow I will explain types of hydride, ionic hydride, covalent hydride and metallic hydride. About that tomorrow I will explain. Understand? Today your assignment, explain, draw and explain the structure of hydrogen peroxide. Draw and explain the structure of hydrogen peroxide. Okay, if you are having book, take your book now. Students, take page number 112. Explain the structure of hydrogen peroxide. From here to here, how to mark. Okay, both in gas phase and liquid phase, the molecule adopts a Q conformation due to the repulsive interaction of the OH bonds with the lone pair of electrons on each oxygen atoms. Indeed, it is the smallest molecule. This is the smallest molecule known to show hindered rotation about the single bond. Okay, hindered rotation because of the single bond. Okay, node resonance takes place here, and only single bond, asymmetrical non-planar structure having here, so it is restricted to rotation. Okay, so because of this it has the smaller molecule. Understood? And hydrogen peroxide has a non-polar structure. The molecular dimension in gas phase and solid phase differ as shown in figure 4.5. Okay, you see the figure 4.5. This in gas phase structure and the solid phase structure. Here the HOO bond angle here 94.8 degree, but in solid phase HOO bond angle 101.9 degree because of the hydrogen bonding. And so bond angle of hydrogen oxygen it expanded, but the bond length for the two hydroxyl group, okay, the dihedral group of the bond length of this dihedral angle, this angle it is reduced here. Here in gas phase 115.5 degree, but in solid phase 90.2 degree. Okay, it is reduced here. So structurally, hydrogen peroxide is represented by the dihydroxyl formula, in which the two OH minus groups do not lie in the same plane. Okay, two OH group it do not lie in the same plane. One way of explaining the shape of the hydrogen peroxide is that the hydrogen atoms would lie on the pages of the partly open book. Okay, it lie like the partly open book, and the oxygen atoms along the spine. Okay, oxygen atom lie along the spine. And in the solid phase of molecule, the dihedral angle reduced to 90.2 degree due to the hydrogen bonding, and the OH bond angle expands from 94.8 degree to 101.9 degree. Okay, understand? Students should study and write and send me through my WhatsApp number. Okay. Thank you, students. Thank you.